So thanks for having me. I'm here basically as a subject of study of what you do. So you can feel like an entomologist looking at the insect. And my background is in medical technology, first in the UK and then here in Spain, working for several companies. Last one being Digenics, but this company is a strange thing because it's a company that was half Belgian, half Spanish. The Spanish actually ended up dominating everything, but we went to NASDAQ. We've been in a global business all the time, and we actually were bought out recently by a Japanese company that has its R&D headquarters in Boston. So my experience of Spain is not very, very rich, although I have been living here and worked with also Spanish scientists, and the original technology that we have actually came from La Paz, from a hospital here in Madrid. So yeah, that's us when we're basically those managers that Stuart was studying, and because I was going to be surrounded by all these smart academics. I remember that when I was studying, I had to come into the tutorials with my homework done. So I read your paper, the survey from 2009. And the content of what I'm going to talk about is basically start with this idea of patents as incentives, which is one of the questions that you have, whether we understand them as managers or not. Then how do we actually see patents? And then to illustrate with 3 examples from my experience why we have these strange behaviors. And finally, whether this is rational or not, and whether there is a better way of looking at patents, which is not the usual incentive model that you use as economists, and whether maybe that can give rise to some heroic mathematics that, leading to papers that you love writing. Okay, so the incentive view, as far as I understand it, and you tell me whether I'm right or wrong, but basically some of this is a market, and this would be mostly what applies in the case of Telefónica, for example. They know the market very well, and some clever R&D guy thinks of an innovation, and then he says, well, this, if I write a patent, will allow me to carve out a little niche in that market. And by doing that, I'll have some incentives that will allow me to convince the product development guys, the process development guys, and the marketing guys to actually put money into developing this new patent. Okay, so that gives me some security that with a patent in sight, that niche that is waiting to be tackled, I can make those investments. In the case of the entrepreneurs, and that's the pun in this presentation, innovation is the assumed role of the startup. In Spanish, it's the idea that el valor se le supone. Yeah, there's no question about not going to patent, for example. So I'll explain that later. But filing patents is one of the activities that are taken for granted by the entrepreneur. We don't question whether we should or we shouldn't in the case of biotechnology and medical technology. Keeping secrets is another. That's basically the question that you have to do. So it is a necessary but not a sufficient condition for fundraising. We know that if we go to a VC, we have to convince the VC that we have some patents, regardless of whether they understand them or not. But the funny thing was that commercial banks were interested in patents. I doubt whether they could ever make any sense of them. But at least they think that those things have some value. So, and it also should keep some competitors at bay. You waive your patent, and maybe people are not going to get in your way. So, on the other hand, the reality is that patents are really seen as a cost of business because we don't believe that they're going to give that much security, as we shall see later. And the real fact is that managers, they don't really have in mind when they decide to patent all the implications that entails, and generally delegate the matter to IP patent attorneys, either internal or external, and these guys will know what to do with these things when problems come. So you could say, we're putting a lot of money into these things, but we don't really want to understand all the difficulties surrounding them. Okay, so it seems like an irrational behavior of the kind that an economist would probably be worried about. Okay, but I'll try to explain that maybe there is a rationale for that. So I have 3 examples. The first one, it's a shame because that was moving, and you could see basically the fruit of my thesis, which was some kind of contours moving with the heart, trying to help doctors understand how the heart moves. But I guess the video is from a long time ago, and it doesn't work anymore in these computers. So anyway, so this was actually an algorithm, and it was an academic patent claiming a way to detect the contour of the heart in these images. And it was the main thing that we had when we started the company. We went to the VCs, and we told them, we want to do this thing, and look how clever we are. But it actually resulted in a failed innovation. Why? For 2 reasons. The market that we were targeting didn't exist, i.e., when you're in the research community, you think, tracking the heart in echo images is going to be very important. The reality is that nobody cares. You do it in MR machines, and they became very cheap, and therefore our idea didn't have that market traction that we expected. Secondly, it's very nice to do, again, heroic mathematics in the lab and come up with these clever algorithms, but the reality is that doctors want something that is super robust, and we were never able to achieve that kind of a level of performance. Okay, and that is the general problem of innovation. Taking the R&D result to the market involves making it very robust and understanding where, really what the market need is. However, we were very lucky, I think, and we discovered other things that we could do and actually take products to the market, and the company was eventually bought by CTA and then Siemens. And the story of this patent is that it was actually bundled up with another package of patents that we have in the company, and it was bought from the university by Siemens, and I made a little amount of money with that. But what I wanted to illustrate here is that this mapping that we had, one-to-one mapping between invention and that niche, is never linear. You never know what is going to happen when you're starting with early stage technology. Okay, second horror story, the pearls of patenting science. So this is kind of the story that we had in Tygenix to some extent. Today, there is technology that allows you to characterize a stem cell, which is the products that we sell. Okay, so we look for cells in the body that can play a therapeutic role, and once we identify them, we say, oh, this cell can be very useful if you use it, for example, to reduce inflammation. That's basically what we do. But we have to characterize that cell so that nobody else can use the cell that we have detected, and we do that because there is technology that allows us to identify this. I don't know, this is well, you see things lying on the surface of the cell and some proteins there. So basically, when you write a patent in this field, you say, my cell contains, say CD90, CD133, CD21 or whatever, and has SOX2, OCT4, and this is my cell, the cell that I want to protect. However, the definition of these things in science, this will be done immediately after the paper is written. The definition of these cells is actually in flux. So it's not very clear what, for example, a mesenchymal stem cell is. Some people describe it by taking some part of it. Some people describe it by taking another part. But in any case, nobody waits for that clarity to be established before patents are written. Okay. So, and also cells change over time. So maybe my cell that I describe in this way will be the same cell, but it will behave in a different way with different markers. So there's a lot of confusion there. However, when we go to our patent attorney friends, they want us to tell them that the cell is stable, you will have these markers, and that is the invention that we're protecting. Okay? So what happens? That there is a mismatch between what science is telling us and what patent attorneys want. So we end up with a high degree of confusion, and if you know the story of the blind Indian sages and the elephant, what happened there was that a sultan sent all these sages that happened to be blind to look at an elephant, and each of them came with a different description of the elephant. And that is basically what is happening. We have lots of patents talking about stem cells, but there's probably more patents than actual stem cells, because people are taking different bits and pieces and describing them partially. And this is a serious problem, because it creates a lot of uncertainty in terms of freedom to operate. And of course, on the other hand, if you're a patent attorney, you should be very happy, because you write these patents, and then you can earn a lot of money from litigation. And this is actually what happens. The third case is one about first mover advantage, which is one of the reasons you mentioned why you want to patent. And the problem there is that pioneers in a field, and again, I'm talking about the special case of very early science moving into development, can claim potential uses of a given technology, but not necessarily have to demonstrate that they have described it fully. So it's likely that they will claim things without having carried all the experiments. But there's the possibility that you can get a very wide protection because the patent system allows you to do that. And if you go to a clever patent attorney, they will be very aggressive, and they will allow you to get if they're good at it, you'll get a very wide, broad scope of claims, so that even if your data, for example, was showing effect in a particular therapeutic area, as in this case, as I will demonstrate, you can claim an effect in other diseases that are collateral, even if you don't have the results, just because it seems likely, and you will get those patent granted, those claims granted. So the problem is that there is, again, a very large risk of litigation. And the positive thing is, at the end of the day, we managers settle these things in the ZUC by bargaining and basically finding an economic solution. Just to illustrate the point, that is our patent in Tygenix. So if you see, it talks about something called fistulas, which are horrible things, and that we can cure with stromal stem cells. So these guys were a bit before us, and they claimed a particular type of stem cell, and they said that it could cure autoimmune encephalomyelitis, multiple sclerosis, and inflammatory bowel diseases. The only reference to IBD, which is what this disease is that paragraph there which says that, theoretically or something like that, this could be used for that particular disease. And there is no evidence there in the patent that actually this could cure that disease. They never carried out the experiments, but the potential is there, and they were the first ones to say it. So even if we're not in IBD, we're in Crohn's disease, which is a variety, we were stepped over by these guys, and of course we could have gone to the court and fight with them, but in the end we just exchanged some money, and we were able to take it to the market. But this is the kind of dangers that we have. Okay, so what do these cases tell us about managerial behavior? First, a patent rarely captures the end goal by the beginning of a discovery process. So it's different from what maybe you can do in Telefonica, where you know exactly where you're going. IP is one of the several possible barriers to entry, but there are many others. So for example, for us, clinical development is a much higher barrier to entry because we can define a therapy for which we have the right data and nobody else has. At the boundary of science and technology, patents are likely to be very imperfect. I mean, not fully describing what we're talking about, and they can also overextend the specification running to other people's inventions. And that creates both gray zones, where you don't know whether you're stepping into someone's foot, or you know that you're not, but a patent is on top of you. Even, there are cases where scientifically you know it has nothing to do with what you're doing, but you have a patent problem. So although patentability is relatively easy to solve, I mean, you can always find a way to write a patent that will not interfere with somebody else, freedom to operate is an arcane. And for that, you have to spend a lot of money on patent attorneys, and there's never a black or white answer. So in these circumstances, what do managers do? They, first of all, they will expect that there will be a deal that will solve these problems at some point, and then, as managers, they will love to do that. And also, they will go in the very early stage for a satisfying solution, something which is, they will keep them going. Basically, they will go through the patenting rituals. They'll try to hire a good patent that has prestige and is expensive to give the right signal. Then they will try to make sure that they have a search result that is satisfactory and there's no noise out there that could prevent you from getting the patent eventually. And basically, then they will put it to sleep until the problem comes again. And only if they have the cash to spend, patent attorneys, they will follow another rational strategy, which is to produce a barrage of patents. So they will patent all the kinds of things that could be surrounding your invention, because then you can also make money by trading these things. So the final point is, does this suggest that there could be a different model for patents? And this is kind of the slide for The Economist. Well, I think they cannot be an ex-ante incentive in the context of these high-tech startups, but you could consider them as an insurance policy. Basically, we take them because it will allow us to talk to different people, to get money, and then maybe to save trouble when it comes in the future. But it's a very imperfect one. And why? Because the small print is rarely read. I mean, managers don't really want to understand all the issues about FTO. It is very poorly understood, and frankly, it is always very difficult to get a very clear white or black answer from a patent attorney. And that is maybe a way to interpret the results they had in the survey. And that's it.